Course 3, Lesson 3 and 4, we are looking at different word problems that involve addition and subtraction in this first lesson, but also multiplication and division in the fourth lesson, of Course 3. When we look at these word problems, we see that we can use variables. That's a big thing here, is using a variable to represent missing numbers. So if we look at a certain example, there's two things that we always want to find with our word problem. What does the variable represent? Basically, what are we missing? What information are we trying to find? And secondly, we need to write an equation to solve it. Remember that an equation has an equal sign and has a variable as part of it. Okay, so with this one here, it says in the first half of the game, Heidi scores 12 points. In the whole game, she scored 27 points. How many points did Heidi score in the second half? Okay, so when we look, we say, what does our variable represent? Maybe we use the letter N for our variable, talking about the number of points in the second half. So let's use N, and that's going to represent the number of points in the second half. Okay, well, we need that so that once we write an equation, we can use what we know, and then once we get to an answer, we actually know what we solved for, instead of just randomly having a variable, and by the end, we have forgotten what it is. So when we go to write an equation, there's a few different ways to do this using addition and subtraction. One way that I like to think about it, we have 27 total points. Okay, those 27 total points came from both the first half and the second half. Well, the first half, I know that she scored 12 points. But for the second half, I don't know. So I use my variable to represent what I don't know. And then we can go ahead and solve this using logic, saying this is an add-in plus an add-in to get our sum. So 12 plus something has to equal 27. So our n would have to be 15. But there's another way to solve this, of course. We could use what we know about equations and how we have to balance things to say, I'm going to take away 12 from each side so that I get n is equal to 15. Now, this isn't the only equation that you could create doing this. Maybe you say, I'm going to take my total of 27, get rid of what we had in the second half, because I know what the first half total was. That's a possibility too. Similar equation, not quite the same, but it will give us the same answer. One last equation you could use, you could say my total minus how many I have in my first half is going to give me how many we have in the second half. So we're able to come up with an equation and solve it for this problem. Let's look at a different one. Let's say we have this one. The hike began at 8,265 feet. The elevation of the mountain is 14,496 feet. Write an equation to show the elevation gained from the beginning to the summit. So basically we have this mountain, okay? We have the mountain, and when we started the hike, it was only at 8,265 feet. But by the time we reached this peak up here, we got to 14,496. If you live in Colorado, you maybe have hiked a 14er before. That's what we're talking about here, over 14,000 feet. But what I want to know, how much did you have to go? How much elevation rise is there between this 8,000 and our 14,000? So what we don't know is the elevation gain. So let's give it a variable, and this is the elevation. Oops, sorry, I can't spell on this board sometimes. There we go. So when we create some equations for this, one way that we could do it is say, well, I know that I started at 8,265. I had to add a certain elevation to get to 14,496. Another equation that you could have wrote is I know that my highest point is 14,496, and with our elevation gain, I could go down that amount and get down to the bottom at 8,265. Or lastly, we could find the difference between the highest point of 14,496 and our lowest point, 8,265. And that would give us our elevation gain. And when you do that, it looks like you would have an elevation gain of, let's see, 14,496. We're going to take away 8,265. So we have a 1, a 3, 2, and 6. When you did that hike, it should be about 6,231 feet of elevation gain. So we're able to use addition and subtraction in these word problems to solve them, okay? In the next lesson, though, we can look at multiplication and division to solve word problems. So let's look at that. So multiplication and division word problems are extremely similar to our addition and subtraction word problems. We still need to find what the variable represents, and we can write an equation to solve it. So in this case, we have an auditorium that has 360 chairs in rows of 15. Our question is, how many rows were there? So maybe we use R to represent the number of rows. Okay? And once again, we can use an equation to solve, but this time we're going to need multiplication or division to solve it. So maybe you say, well, if I have those 360 chairs, and I know that there are a certain amount of rows, that can give me that we have those 15 chairs in each one. So we take the total number of chairs, divide it by how many rows we have, and we get how many is in each row. That's one way. Or maybe we say I have 15 chairs and a certain number of rows, so I get 360 chairs. Lastly, you could say maybe I do 360 and divide it by how many chairs are in each row so that I can figure out how many rows there are. All of these equations will work, and we can figure out how many rows we have. Okay, so when we do that, all we have to do is do 360, divide it by 15. Well, 15 can go into 36 2 times. We put it in, we get 30, and we have 6 left. Bring down our 0. 15 can go into 60 4 times. So our final answer is 24. There are 24 rows in the auditorium. Maybe let's look at another one. How about this one? Corey sorted 375 quarters into groups of 40 so that he could put them into rolls. How many rolls can Corey fill? This is very similar to the one we just saw. Maybe, in this case, our variable represents the number of rolls he can make. We have a total of 375 coins, but we don't know how many rolls, so maybe we divide by our number of rolls to get how many is each one. And we know that there is 40 in each. Okay, so that's one way. We could say 40 times the number of rolls we have is going to give us how many total coins. And lastly, we could say, well, we just have 375 divided by how many can go in each roll to give us the number of rolls. Well, when we do that division, 375 divided by 40, let's see, 40 can't go into 37, but 40 can go into, let's see, 360. Okay, so let's say we have 9. 9 times 0 is 0. 9 times 4 is 36. And I have 15 left over. Well, I can put a decimal and another 0, bring it down, and that can go in 3 times, 120. and we have a 3, bring it down, and so on. But when we notice what's going on here, we have a decimal. Can I have a fraction of a roll? And you would probably say no. So there's a couple ways to think about this. You can say, I need 10 full rolls to have all of those quarters into rolls. Or we can have 9 rolls completely filled, and then we need a few more quarters to get to our 10th roll completely filled. Okay? So when we look at those fractional answers, we need to logically think about, in real life, what would we do? Okay? So, using multiplication and division to solve word problems. I hope this was helpful for your homework and for studying.